there and welcome back to 355 Code. Today we have another beginner JavaScript tutorial for you, and this time we're going to do something really cool, which is create our own blockchain. And we're going to be doing it using very simple JavaScript concepts. So if you know what functions are, what arrays are, and what objects are, you can pretty much follow through with this tutorial. There may be a concept here or there which you don't understand, but we'll do our best to explain it so that you can follow through. If you like this tutorial and you want to see more, please like and subscribe to our channel. So let's get started. For those of you who don't know, a blockchain is basically, in very simple terms, a chain of blocks which each block contains the entire block before it. And we're going to see how that exactly works soon. But it's a secure way to store data that is very hard to manipulate and alter and tamper with. So I think that creating your own blockchain is a really great way to understand the concept, and that's what we're going to try and do here today. So the first step of creating the blockchain will be to create a certain block of which our chain will be made up of. So this block is going to be an object, and we're going to create it using a function. So let's start off by creating a function. And I'm assuming that you know how to do this. If you're not sure how to do this, I recommend you check out some of our other introductory videos. And we're just going to call it create block. And this create block function is going to have several parameters. So first of all, it's going to have an index, which is going to keep track of what number block it is in the chain. It's going to have a timestamp, which is an important part of a blockchain, which is basically what date and time this block was created on. It's going to have some data. Okay, the whole point of blockchain is to store data, whether it's transactions or contracts or something like that. So that's a very important part. And the last thing will be the previous hash. And this is basically what makes this whole blockchain into a chain, because each block has the hash of the block that came before it. If you're not sure what a hash is, keep on watching and you'll get a better idea of it soon. So, okay, that's basically what our function will take. And this function is going to create an object, as I said. So let's create this object here. We'll declare it and we'll call it block. And this block will be made up of an index, which will be the index that was entered in the create block. It'll be a timestamp, which will be, these should be commas, which will also be the timestamp that was given here in the block. Data, which is also same, previous hash, and the last thing, which we don't have yet, is the hash itself. And what we need to do is basically create our hash now. So for those of you who are not familiar, a hash is basically a codified representation of some kind of data. So we give it some information and it creates a certain code out of it that sometimes can or cannot be reversed into the previous version. But the important part here is to remember is that if we take different data, we're going to get different hash. And that's basically what we're going to use later on. So there are many ways to create hashes. There are libraries that are built specifically for this purpose. But since we wanted to keep things really simple, we're actually going to build our own hashing function. And this is not a very secure hash, but it has the same functionality that a more advanced hash would have, and that's good enough for our example. So let's create another function, which is going to be create hash. And this function will take a string, and it will create our hash. So the way we're going to create the hash is we are going to take each character in the string and turn it into numbers. And the way we're going to do that is using the character code at method, which basically takes a character, it could be a letter, it could be a number, and it turns it into its code, right? The way the computers interpret things that we type is that each letter on the keyboard has a numerical code, and that's basically what we're going to be using. Again, it's a very, very simple quote-unquote hash. You'll see that it has several problems, that our hashes will keep on getting longer and longer because we're not really keeping them consolidated to a certain length of the string. But for example purposes, it works. So let's declare a variable called new hash. And for now, that'll be equal to an empty string. And then basically what we're going to do is we're going to set up a simple for loop. And as long as I is smaller than the length of this string. And this string is basically different elements of the data of our block that we pass into it, which we'll see in a minute. And then I++. So basically we're going to run through each character in the string, and for each character we're going to change it into a number, which uses that method that I mentioned before. So if you don't understand this part of the tutorial, that's cool, because this is really a concept that's not essential. It's important for the blockchain, but it's not essential to understand hashes to understand how the blockchain works. So if you need to just copy my code here, or use an outside hashing library without completely understanding it, that's fine, and you can work on that later. And this new hash will basically be equal to a string with all the numbers that we've aggregated here. So what are we going to pass into this string that will create our hash? So let's really put that over here on top. So the hash for each block will be equal to simply create hash, and the string that we're going to pass in is just index plus timestamp plus data plus previous hash. Okay, and again, this is a very simplistic way of doing this, but basically, if we don't have every single one of these parameters, we won't be able to create a hash. Okay, and that's basically what we want to try and achieve here. And now we have our basic create block function. So let's really just test it out. So let's call create block, and let's say it's index 3. Timestamp, we'll just take new date because we're creating it right now. This basically passes on the date and time for this very moment. The data, let's just say hello world. And for previous hash, we'll leave blank at the moment. Okay, and now let's, at the end of create block, let's just console.log block. Excellent. Now let's run the code, and you'll see that we have here a block, but for some reason we do not have our hash. And now let's try and think why that happened. So we basically need to do some debugging here. So let's let's add a console here at the end of our hashing function, and console new hash. And we see we do have a hash. Okay, so we are getting a hash from our, so this create hash function is working. So now let's try and see where we went wrong here. So let's actually, instead of creating a hash here, okay, I'm going to block this out, and instead let's console this information here. Okay, let's just make sure that we got everything here right. And let's run that. Okay, so, because hash is not defined here, that's fine. And here is the, this is the stuff that we passed on into our hash. So let's try and see where we went wrong here. And this is part of coding, so debugging, it's going to happen. And excellent. So here's the problem, that our create hash function, it doesn't return anything. So when I was calling the create hash function over here, it was actually just running this code, console hash, and then it's done. It doesn't tell it to actually pass on a certain value to our hash variable. So instead of consoling here, we're actually going to return new hash. Okay, and that will basically pass this value on to the hash here. And now let's run our code again. And now we see we have our block. Okay, so we have a full block, index, timestamp, data, previous hash, and hash. Excellent. So that's really the first step and the fundamental part of our blockchain. And now we actually want to string these together into a chain. So to do that, first of all, let's declare our blockchain. So we'll do that the very first thing in our code. And it's just going to be equal to an empty array. And this is the array that we're going to push our blocks to. So let's create another function that adds blocks to the chain. So this function is going to be called add block. And it'll just take user input. Okay, and this user input is basically our data. Because we don't actually need the user to give us the index, the timestamp, the previous hash, all that stuff is computed independently. We actually just need the data from the user. And then we will basically pass on all the information to a create block function. So let's first declare all of the variables. So let's say index. How are we going to know what our index is? So our index will pretty much be blockchain .length. And the reason for this is that our first, equals here. Right, our first entry to the chain, which is going to be the Genesis block, we'll talk about that soon, that will have an index of 0. And then each block will go up by 1. And blockchain.length will always have a length that is equal to what we want the next block index to be, because the length of an array, if you remember, it doesn't start from 0. So if I asked for the length of an array with 1 entry, it'll be 1 even though the index is 0. So if you need to wrap your head around that, you can pause the video and kind of try and work that out. But this is how we're going to decide what the index should be. The timestamp will do just like the block that we made ourselves. That will be equal to new date, right? Just the very moment right now. For our data, that'll be the user input. And now we have to get our previous hash. And the way we're going to do that is get the hash from the block before. So basically we want to access the blockchain array. And the index that we want to access is the length of the blockchain minus 1, right? Because of what I just explained about how arrays are indexed and how length is measured, right? So this will be blockchain.length minus 1. Okay, so now we're accessing the previous block on the blockchain, and we want to get its hash key. Okay, so that's what our previous hash is going to be. And now we just have to call create block and pass in all of this information, which are the arguments for our function. And it's basically the same exact thing here because I've been using the same variables. And great, now when we call add block, it should add a block to our blockchain. So instead of using our create block function, we just need to say add block and let's say 5. Okay, I'm creating a block and it's just going to have the data 5. So let's run our code, and we have a problem. And this problem was, I knew this was going to happen, so this isn't a bug, but basically we are trying to access the hash, right, of our previous block in the blockchain, but there is no block, so there is no hash, so we can't create another block. And this is where the Genesis block comes in. So what we are going to do is we are going to create another function. Let's put it right up here before create block. And this is going to create our Genesis block. And this thing is going to happen only once for each blockchain. And what we're going to be doing here is, sorry, let's call this actually create Genesis block just to be a little more clear. And what we're going to do is we're basically going to create a block, and it's going to be called our Genesis block. And it's an object just like any other block. The only special thing about it is that we predefine what its contents are. And we're going to give it the index of 0, right? Because we said our blockchain is going to start from 0. And the timestamp will be new date, okay, whenever this blockchain is initiated. And we are going to give it data, which will just be Genesis block. And we are going to create a hash for it. So the hash is going to be create hash, and we're going to pass in the data from this block, which is 0, new date, and sorry, this is going to be a string. Excellent. And Genesis block. So this code is not very elegant, but it's functional, and it's, I think, very clear, and that's what we're trying to go for here, really to understand the concepts and just kind of understand how blockchain works and how to create it very, very simply with JavaScript. So now that we created our Genesis block, let's push it onto the blockchain. So blockchain dot push Genesis block. Excellent. So now whenever we call this function, create a Genesis block, that will initiate a blockchain. So let's really call that here on the bottom. And any other additions to the blockchain will have to come after create Genesis block. So now let's try out our code. And here on the bottom, let's console log blockchain. Okay, so we want to log the entire chain so we see what's coming out at the end. And now let's run our code. So we see that our blockchain only has one object, which is the Genesis block. So that's not very good. Let's take a look at our code. And we see that in the add block function, we never actually pushed the new block onto the blockchain. So let's add that here. And sorry, this is actually going to come inside the create block function. Okay, because here we don't actually have the block object, so it would be kind of hard to push it onto the array, and we'll do that right here. Okay, so blockchain.push block. Okay, and now let's test out our code again. And let's go to the bottom where we have our, you know what I'll do? Let's comment out this, or we could just erase it actually, and then run the code again. So we just really get the entire blockchain, 2 objects, amazing. We have our first Genesis block, and we have a second block which you see has a previous hash which is equal to the hash from the Genesis block or the block before it, and it has a new hash which is based on all the new data. And you can see these hashes are getting pretty long, which is because our hashing system here is very, very, very primitive, but it's serving its purpose, and it's works for the sakes of this video. Great, so now we have a blockchain. We can add more blocks. Let's say 20. Add block 3. Okay, so we're just basically, you could think of these as transactions, like, you know, give him $5, give him $20, or 20 Bitcoin, or whatever. And that's basically what's going on here. And, you know, there could be more data, like a recipient or a sender and stuff like that. And each one of these is logged onto the chain. And let's try and run our code again. Great, we get another chain. And yeah, we could check, let's say, so the hash here starts 4977, and then we can see here, previous hash 4977. I'm going to assume that the rest is correct without reading it all. And now what we want to do is basically make sure that nobody is tampering with our blockchain. So basically, after we add a block, we are going to check the validity of the blockchain. So let's create a function. We'll create it here right above add block, and this is going to be check validity. Okay, and basically we want to check here for 2 things. One is that the hash of a certain block is equal to what it's supposed to be, and that the previous hash is equal, the previous hash of the next block, let's say, is still equal to the hash. And that will kind of verify that we have not made any changes and tampered with any of the blocks. So let's actually get into it, and then you'll see a little bit more about how it works. So we're actually going to run through our entire blockchain, right? We need, after we make a certain change, we want to check all the blocks to see that we haven't tampered with anything. So, okay, I equals 0, and as long as I is smaller than blockchain dot length, we are going to I++. Okay, so this should run through our entire blockchain. And what are we actually going to be doing in this for loop? So let's first declare some variables. So let's say the current block will be equal to blockchain I. So this is for each one we're checking. And we'll say previous block will be equal to blockchain I minus 1. Okay, because all these comparisons are going to be between a certain block and the block before it. And now let's start with our first check. So the first thing we want to check is if the current block.hash, okay, is equal to the hash that would be created from all the data. Because remember we said one set of data will create a certain hash, and then if you change any element of the data, then the hash will change. So if we check that the current hash, okay, what it says under hash, is equal to the same hash that would be made from all the data currently inside of the block after any changes were made to the blockchain, then that should mean that this block has not been altered. So if, okay, it's not equal to, and basically we're going to be creating a hash here. And the hash is going to be created out of all the current data in the block. So it's going to be basically current block dot index, right? And also has to be in the correct order. Current block dot timestamp plus current block dot data plus current block dot previous previous hash, not block. Okay, and basically this is creating a hash out of all the data that is currently inside of the block and seeing if that equals to the current hash that's under the hash key inside the block. And if we see that these are not equal to each other, that means somebody has tampered with some of the data in the block. That's either the index or the timestamp or the data, etc. They'll probably want to tamper with the data. Okay, so if these two are not equal, then we are going to have our function return false. And false will just be not valid. Okay, this is not valid. So let's just use a typo here. Fix that. Great. So that's the first thing that we check. But let's say we have someone really smart, and what they do is they first change the data, and then they decide, okay, we'll just also change the hash, and that way this will come out true. So basically what we need to check is that the hash that's listed here is equal to the what's listed under previous hash for the next hash in line. And basically what that means that if somebody wants to change any one of the blocks, they will have to change the hash that comes after it, and the hash that comes after it, and the hash that comes after it, because each of the hashes is built on the block before. And that's the fundamental concept of blockchain. So this, let's check simply by comparing the what's listed under previous hash in a certain block, and if that is not equal to the previous block's hash, then we have a problem and we are going to return false. Okay, and this is going to check for each of the blocks in the chain. We're not only checking a specific block that may or may not have been altered, but basically all the blocks. And if none of these come out to be true, then we will just return true, because that means that our blockchain is valid, okay, that no invalid alterations have happened. And basically what we can do is we could either call this check validity kind of at the end, or we can actually call it within each time we add a block, which kind of signifies an alteration into the blockchain. So let's check validity after we add blocks. And now let's run our code again. Sorry, so let's console, right? Because check validity is just returning false or true, but we're not actually reading it anywhere, so we actually have to log it. right? And later on, if we wanted, we could put some kind of condition that, if the blockchain equals false, reject this block or reject this change or something like that. So there would be like an intermediary step where after someone tries to make an alteration, it checks the validity of the chain after the alteration and decides if it's going to accept or reject this alteration. So, but for our sake, we're just going to check it after we make additions to the blockchain. So let's check the validity, and we got false, 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 false. So that means that we have some kind of issue here. Let's take a look of our code and see what might have caused this bug. Okay, so we're going through the blockchain and we're checking if the current hash is equal to creating a hash, right? And if that's true, we should enter false. So let's actually let's add a console to see which one of our if statements is returning false, because we have two statements here, and that can help narrow down our problem. So let's console.log 1 or console.log 2. Excellent. And now let's run. Right, so it's 1. So we're kind of falling here on this issue. And the reason that this is happening is because we are checking the Genesis block. And for the Genesis block, we don't have previous hash. So basically what we want to do is to check validity only after the Genesis block. So let's try running that again. And now we get everything is true. Okay, so the validity for Genesis blocks will have to check in a different way. Or it must be secured in another manner. And our validity check is really only for everything that comes after the Genesis. Let's actually leave this in, because this will be important for demonstrating something soon. So let's say we try to make a malicious manipulation of data within our blockchain. So let's say I just say blockchain, right? I'm a hacker or something, blockchain, and I access index 1, and I say .data, and I change it to 100. Okay, I change a certain transaction and I make it worth a lot more than it actually is. And then if we run our code, boom, okay, we get a false, okay, because we made a change to the data that is not by adding a block, okay, it's by making an alteration to a block. And boom, alarms, and then, that transaction is not accepted. We go back to see how the data was manipulated, etc. Okay, but let's say I'm very smart. So after I change the data, I decide to change the hash as well. So blockchain 1.hash equals, and now basically I use all of the current keys, all of the current data from this blockchain. So it'll be equal to create hash, and we're going to use blockchain 1.index, right? I'm just getting the current values, plus blockchain 1.timestamp, plus blockchain 1 dot data plus blockchain 1 dot previous hash. Okay, and again, this isn't extremely elegant, but I hope that it is clear what we are doing. And let's try and run our code again. And we see we get a false, but our false is on 2, okay? Because basically where we failed here is that we compared the hash to the previous hash, and it was incorrect. Okay, so basically we changed the data, we updated the hash, okay, so great. So now the hash is equal to the hash that it should be equal to, but if I take this hash and now compare it to the next block after it, the slot where the next block says previous hash, we have an inconsistency. And so basically I would have to then go into the blockchain and change the block after it, and so on and so on and so forth. Okay, and that would be a much more complicated endeavor, especially because of how blockchain is distributed, which is a whole nother topic. So congratulations. If you followed along, then you have created your own blockchain. It's very simple, and it's pure JavaScript, using very simple concepts such as array, object, function, variables. You don't need anything more complicated here. Obviously, if we used some more advanced code, using classes, for example, creating our own methods, then we could probably make our code a little more clear, a little more concise, but we really do have the fundamentals here. And I hope you enjoyed this tutorial. If you want to see more videos like this, I encourage you to subscribe to our channel and follow along, and I hope to see you next time.